Hey everybody, Mr. Judson here. How you guys doing? It's June 3rd, and we're still reviewing. So let's see, we're backtracking. So we reviewed over Chapter 8 yesterday. Today we'll review Chapter 7, which is finding the area between two curves and taking a region and rotating it around a line to create a solid. I should let you guys know, we haven't done everything that we normally do. Normally in Chapter 7 we would find the length of an arc, or a curve. We'd also find surface area when you revolve something around a line. Those two things are real important because they had to do with our hot air balloon project, which we didn't do, and so I went ahead and skipped that. There's also some things like how much work does it take to pump water, how much work does it take to lift something like a rope or a chain, and we didn't get to that stuff. That's partly because we had a few weeks where we did nothing, and then we were doing two lessons a week and eventually up to 3, and you're just not going to get everything, so we have a few things here that we've missed, and that's okay. I think moving forward most people will be fine, but I think realizing that we still have a few holes is probably important. And I don't know what people are going to major in college. If someone majors in engineering or something like that, those are some holes or some gaps that you're going to want to fill at some time. And I'm sure that any professor at college would understand and be more than willing to help out. So anyway, Chapter 7. So let's start with finding the area between two curves. And if you remember, we said that the area equals the integral from A to B of the top curve minus the bottom curve, dx. And if for some reason we're doing something sideways and it's a dy, it's the curve to the right minus the curve to the left. The one to the right would have larger values than the one to the left. And our A and B values are the x coordinates where these two graphs would intersect, or if it's sideways, the y coordinates where they intersect. So let's start with this. Let's find the area between f of x, which is a negative x squared plus 4x plus 2, and g of x, which is x plus 2. Okay, we want to find the area between those two curves. You guys go ahead and try. Alright, so I guess first I probably would want to know what the graph looks like for this. And I'll just draw, kind of a general sketch. This is a straight line with a slope of 1, goes through the y-axis at 2. So something like that, where that's 2. This would be an upside down parabola, and so I'm assuming that that's going to go somewhere above. I don't really know exactly where, but what I need to do to start is I need to find these 2 points of intersection. And you get that by setting the two equations equal to each other. So I'm going to say that a negative x squared plus 4x plus 2 is equal to x plus 2. And so anytime we have exponents, we want to set it equal to 0. So I'll move this over and subtract it. So I'm going to have a negative x squared. If I move that x over and subtract it, I now have 3x. Move that 2 over and subtract, I've got 0. And so then if I factor out, I'm going to factor out a negative x. Then I'm left with x minus 3. And so I can see that my points of intersection are at x equals 0 and 3. Alright, so what I want is the integral from 0 to 3, top curve minus bottom curve. So I've got a negative x squared plus 4x plus 2 minus x plus 2, and then dx. So let's see, if I combine these, I then get the integral from 0 to 3. of a negative x squared. Subtract that x from here, I get plus 3x, and then 2 minus 2, that's 0. So dx. I don't want you guys to think that we always get the same thing here that we had here. Normally I kind of like for this to be positive, so I might have moved it to the other side. I don't know why I didn't this time. Alright, so let's integrate this. That means I have a negative x to the third over 3 plus 3x squared over 2, and I'm going to evaluate that from 0 to 3. So if I plug in a 3 first, I get 27 divided by 3, that's 9. Here I get 9 times 3, that's 27 divided by 2, that would be 13.5. Oh, this should be a negative 9, right? So 13.5 minus what I get when I plug in a 0. That'll be 0 and 0. And so what I get is 13.5 minus 9, that's 4.5 square units. Don't forget the label, okay? And also, you know, make sure we understand, am I talking about area or volume? Because that's what decides our units, right? Area is the number of squares to cover something. Volume is the number of cubes to fill something. All right, let's try another one. All right, so on this problem, we've got a region that's bounded by, so remember that means boundaries. This equation, y equals 6 minus 2x minus x squared, and y equals x plus 6. And this is to be rotated about the line y equals 3. And we want to find the volume. So we had 3 different methods that we talked about. We had the disk method, the washer method, and the shell method. And on the Central Washington test, we're not going to be told which method to use. You guys get to decide that for yourself. So whichever one you think is best. Some people who really like the disk and the washer method, if you want to use that, as long as you can, that's fine. Shell method kind of always works. I always hate to say always. And I know for a fact that it doesn't. There are some situations where the shell method would not work. But I know some people like the shell method because it's one method instead of 2, and they choose to always use that. And so, yeah, whatever you guys want. Okay, so let's go ahead and see if we can solve this. All right, so I probably want to start with a graph. By the way, I'll tell you guys, we're going to go ahead and solve this, but I'll tell you guys something that's kind of nice. And I had mentioned this before. A lot of times, you know, on the AP test and the Central Washington test, they'll say set up the integral and you do not have to solve it. Well, that happens on our Central Washington test. So they're going to ask us to set up the integral, but you don't have to solve. We'll go ahead and solve this one. But just know that on the test. All right? Okay, so if I graph this, let's see, I've got y equals x plus 6. So there's my y-intercept. And slope of 1. So this graph will look something like that. Here I have an upside down parabola. So I'm going to factor out a negative sign and then just see if I can factor this and see where it crosses the x-axis. Minus 6. So no, I can't factor this to see where it crosses the x-axis. But I do see, if I plug in a 0, I get the negative of a negative 6. That means it's going to hit this point right here on the origin. If I plug in a 1, I get 1 plus 2, that's 3, minus 6, that's a negative 3, and the opposite of that is a positive 3. So I'm going to have a point right here. And let's see, if I plug in a 2, I get 4, plus 4, that's 8, minus 6, that's 2. Opposite of that is a negative 2. So now we're down to right here. So if I plug in a negative 1, I get positive 1, minus 2, that's a negative 1, minus 6, that's a negative 7, and then the opposite of that is a positive 7. So at negative 1, we're right here. That might be the vertex. Do you guys remember the vertex is at negative b over 2a? So if I go back to the original equation, opposite of that would be 2 over 2a. That would be a negative 2. Yeah, so that's the vertex right there. So this thing is going to go down like this, and it's going to go like this. What I really want is this region right here. I want that region to be rotated around the line y equals 3. So let me just erase, and what I'm going to do is I'm going to rotate that about this line right here. So if I rotate this around, I'm going to hit this point. This isn't quite as far, it's right about there. There's a straight line and then something like that. And there's going to be a solid shape there. So if I was trying to figure out how to do this, I think my first thought would be probably the washer method. And so here's my washer. It's going to be hollow on the inside. And so what I want to do here is I want to do the integral from a to b. I've got, you have to think, how do you find area? It's pi r squared. So this would be big R squared minus little r squared. And then this is a dx value. It's running parallel to the x-axis. So I want everything to be in terms of x's. So I guess the next thing I have to do is I have to figure out my a and b values, where these intersect. So 6 minus 2x minus x squared is equal to x plus 6. This time I'll go ahead and move everything over to the right-hand side. So that'll become a positive x squared. When I move this over and add it, I get plus 3x. When I move this 6 over and subtract, I get 0. So factor out an x, and I get x equals 0 and negative 3. So this integral is going from negative 3 up to 0. That's how the washers stack side by side as you set them down there. So I've got pi times the integral from negative 3 to 0. And then I need my big radius squared. So the equation that's farthest from our axis of rotation is the parabola, the upside down parabola. Also remember, this is the original part right here, not this. This is what we got from rotating this thing around the line y equals 3. So when I figure out the radius, I want to make sure I use something from up here. Okay? Something from up here. Alright, so I want, let's see, I'll draw the radius in blue. If this is my large radius, right here, that's this y value minus this one. This one's always at y equals 3. This one is not, always at some number. So I need to call that y minus 3. And we know y is equal to this right here. So I've got 6 minus 2x minus x squared minus 3. There's my large radius squared. And now I need the small radius, which would go from this point down to here. And so this y coordinate, or y value, comes off this line right here. So little r will be y minus 3 as well. But I got to put this stuff in place of y. So minus little radius is going to be x plus 6 minus 3 squared. And this whole thing in terms of x. And so I'll clean this up a little bit. I've got pi and then the integral from -3 to 0 of, let's see, 6 minus 3, that's 3. So I've got 3 minus 2x minus x squared, and I have to square that, minus x, and then 6 minus 3, that would be 3, and I have to square that. So on the Central Washington test, that's where we would stop right there. I have set up the integral, but I don't need to compute the value. Okay? I think I said at the beginning of this problem, we're going to go through and find the value anyway. Squaring this is kind of a mess, and it just makes the integral a little bit harder. I know in this chapter we just punched everything into the calculator and got the answer that way. So I'm going to say this equals whatever. Since Central Washington's not going to ask us to solve it, let's just not worry about it here. Alright, so this time I've got the region bounded by the line y equals e raised to the x over 2, y equals 0, and x equals 4, and this is being rotated about the line y equals -2. So again, let's just set up the integral. Let's not solve it. Okay? So you guys go ahead and draw a picture, set that up, and then write the integral that would give us the volume of that region. Alright, so again I'm going to start with a graph. Alright, so when I look at this, what I remember is that this is an exponential function. Any number raised to the x power, it's going to look like this. Okay, the fact that it's x over 2 means it just won't go up as fast. So I'm going to do something like this. Okay, there's my exponential function. And it's bounded between that and y equals 0, which is this right here, and x equals 4. Forgot to write something down. X equals 0 should have been in there as well, so we've got this boundary right here. And we're going to take that and rotate it about the line y equals -2. So what I'm going to get is a second piece like this, and kind of an upside down exponential curve. We don't really need this part right here. And so again, this sort of looks like a washer method, right? There's my washer. Here's the hollow part on the inside. And again, this is running parallel to the x-axis, so we're setting up everything in terms of x. So I'm going to have an integral. As I stack these washers side by side, they're going to go from 0 up to 4. My big radius is going to be from here down to here. Okay? Remember, when we do this, we always think larger value minus smaller value. If I'm wrapping around the x or the y-axis, those smaller values always end up being 0, but here it's something else. So I want this y value minus this y value. This y value is always going to be at -2. Okay, so down here I'm going to say big radius is y minus a -2. So that means whatever this y coordinate is, I'm really just going to add 2 units to it. And so this y coordinate is e to the x over 2, and then plus 2. There's the big radius. Alright, so I want e to the x over 2 plus 2 squared minus the little radius squared. And so when you draw the small radius, it's always going to have the same value. As we slide this segment right here back and forth, this point always sits on the x-axis, this point always sits on the line y equals -2, and so that distance is 2. And so what I get is 2 squared, and then dx. So the integral from 0 to 4 of e to the x over 2 plus 2 squared minus 4 dx. As you guys write these, make sure you pay attention to things like parentheses and brackets. Whatever you're taking the integral of with respect to x, all of that should be enclosed in something. I don't care if it's a bracket or a parenthesis. Doesn't really matter. Or even those squiggly parentheses. Doesn't matter. We just have to have something there to group that. And in this radius, inside parentheses squared, we want to make sure we've got those in there as well. So there it is. I have set up the integral, and I do not need to compute the answer. All right, let's try another one. All right, so this time we've got a region that's bounded by y equals the square root of x, y equals 0, and x equals 4, and it's rotated about the line x equals 6. And let's just see if we can do this with the shell method. We'll just practice it so that we're at least aware and feel good about it, okay? So you guys go ahead and try that. All right, so once again, I want to draw a graph. Square root of x looks like this. I want y equals 0 to be a boundary and x equals 4. So there's my region right there. And I want to rotate that about the line x equals 6. So that means I'm going to have another shape over here that looks kind of the same as that. Again, this could be another washer method, but just so that we're doing something here with a shell. So remember, the shell is like a paper wrapper that goes around like a Campbell's soup can. And it's got this little tiny bit of thickness to it. And so what we said back in chapter 7 is, whatever direction this right here runs, that's how I'm going to decide if I'm using dx or dy. Go out to the ends of that cylinder, and this is parallel to the x-axis, and so I want to call that dx. Okay? Alright, and then the volume of this cylinder, remember it's the circumference around times the height, so that's 2 pi times the radius times the height times that little bit of thickness, which is dx. That's our formula for the shell method from A to B. Alright, so here's what I've got. Again, we're just going to set it up. We're not going to solve the integral. So I've got 2 pi integral from these shells. As you start putting them around each other, the farthest one out here is going to be at x equals 0. The last one and the smallest one on the inside will be at x equals 4. So we're going from 0 to 4. I've got the radius. So let's see, my radius is going to be from this point right here to this point right here. And I always want to take larger value minus the smaller value. So this value is always going to be at x equals 6. This will just be at some x coordinate between 0 and 4. So what I want is 6 minus x. There's the large radius. And now I need the height. The height of this thing is going to be right here. And that's just some y coordinate. And y is equal to the square root of x. So square root of x and then dx. Now if I had to solve this integral, this one's not too bad. I would just go ahead and call this x to the 1/2. I would distribute it and then write that out, then add 1 to the exponent and divide by the new one. But we were just trying to set this up so that we could solve it and then stop there. That's what they're going to ask us to do on the Central Washington test. So as you're doing homework this week, if you check the back of the book, they're going to give you final answers. We could also, remember, solve this integral on our calculator. So if you guys wanted to, you could graph this, go to y equals, and just punch in parentheses 6 minus x times the square root of x. And let's say I probably want to get that 2 pi in there as well. So let me just put that in the beginning. I'm essentially moving this back to the inside. Okay, so I'm going to insert 2 pi, and then I'll graph that. And what I want to do is I want to integrate this from 0 to 4. So I can't quite see all of my graph there, so I may need to change the window. I'm going to go on the x or the y-axis from 0 to 100. There we go. Now we can start to see the graph. Okay. So now I'm going to do second calc, option 7. I want to go from 0 to 4. And it's working, and there it is, 120.637. And this is volume, so that would be cubic units. So if you wanted to just check and see if you were getting this right, go ahead and graph, move the 2 pi back to the inside, go ahead and graph that. And then once you have it graphed, do the integral from 0 to 4, and then check that in the back of the book, and that way you'll know if you're doing things right or not. You can also look on Calc Chat, and I'm sure that they would show this integral before the final answer. All right, that's what we have for today. So let me get you guys an assignment here. So we're on number C21, page 513. We'll do 7, 9, 25, and 29. And kind of like yesterday, we're preparing for a test. 4 problems really isn't that many. If you want to do some more, pick a couple, pick some odd ones. Make sure they're ones that we talked about in this section. I wouldn't do anything on work or fluid pressure. That's something else we normally talk about, is the pressure of water pushing against a window. And so anyway, avoid those. But anything that has to do with area, those would be reasonable ones to practice. All right, so let's see. Today is Wednesday, which means I'm down at the hospital. My wife is having her surgery done. I'm not able to be at home preparing videos, so I will be home tomorrow on Thursday, but it's already too late to prepare it. But I've got a worksheet that I'll just post, and you guys can find that on the Sway page. All right? There we go. That's it. I guess I'll say have a good weekend now, because I won't see you guys on Thursday. So take care. Stay safe. Bye.